so let's talk about mineral color. Now, you might think mineral color is a good, simple characteristic to use for mineral identification. After all, minerals exist in all different colors. Why not use that as a jumping off point? But the fact is, there's a problem. There's a problem with using color to identify minerals, and let me explain what that problem is. Take a look at this necklace. The beads that make up this necklace are all made of quartz. That is to say, they are all the same mineral. So clearly, quartz exists in a variety of colors. And so I can't count on quartz being white or blue or green. It could be any of those colors. That poses a problem for mineral identification. Similarly, take a look at these minerals. I think you'd agree they're all purple in color. But the fact is, each of these is a different type of mineral. And so using color is not a reliable characteristic for identification. So how do we measure the hardness of a mineral? Well, in order to do this, we need a piece of glass. Now, glass has a hardness of 5.5. It falls in the middle of the Mohs hardness scale. And I will take a mineral sample. This is a piece of potassium feldspar, and I will try and scratch the glass with the feldspar. In order to do this, you have to have the glass flat down on the table, and you take your sample and you have to push. Not only are you looking for scratches on the surface, but you're also trying to listen and feel to see if the sample is grinding into the glass or not. If it does scratch the glass, then this mineral has a hardness greater than 5.5. If it does not scratch the glass, then it's less than 5.5. Luster refers to how light reflects off of the surface of a mineral. For our class, we will be using two types of luster, metallic and non-metallic. Metallic minerals have a metallic appearance. What I mean is that they are gold or silver and actually look like a piece of metal, like this chunk of galena or this chunk of pyrite. Notice how they look like they are metal. So those have a metallic luster. Then there are other minerals, like this olivine, which does not look like metal, and this has a non-metallic luster, as does this gypsum. It does not look like metal. So when you're doing a luster test, all you have to do is ask yourself, do the samples look like metal? If so, they are metallic. Or do they not look like metal? If so, they are non-metallic. Breakage is probably the hardest property to identify. Minerals break in one of two ways, cleavage or fracture. Fracture is when a mineral breaks randomly. If you look at this piece of olivine, you'll notice it has a jagged, irregular shape. It looks like it was just smashed into a random shape. This is referred to as fracture. This mineral displays fracture. This red hematite also displays fracture. You notice the random, irregular shape. As does this quartz sample, random and irregular, and this pyrite sample, random and irregular. That is fracture. However, there are some minerals on Earth that break in very unique and predictable ways, like this piece of calcite. It almost looks like it was cut this way with a saw, but in fact, this is the natural way that calcite breaks. This breakage is referred to as cleavage. You'll notice it has predictable flat sides, and if I were to smash this with a hammer, the little pieces that it created would be shaped similarly. This piece of galena has a really interesting type of cleavage. If you look at it carefully, you'll notice that it too breaks at these predictable 90-degree angles, flat sides. This was not cut this way. This is how it naturally breaks. As does this halite. This displays cleavage. There are some other types of cleavage as well. This is called biotite mica, and it looks like a flat sheet. What's neat about biotite mica is you can actually peel off thin pieces of it, and that is a different type of cleavage. I have a piece of peeled off biotite mica here. You notice it's paper thin. This was peeled off of a larger sample. So just to sum up, cleavage is predictable breaking, like this calcite. Fracture is random breaking, like this olivine. Streak refers to the color of a mineral as a powder. In order to make a powdered sample of a mineral, we use streak plates. These are ceramic tiles. One is black and one is white. And what we do is we place them on the desk and we rub our mineral samples against them to create some powder and see what color that powder is. Let me demonstrate. This is a piece of red hematite. I'm going to take this hematite and I'm going to gently, one time, try and draw a line. And what you notice is that it has a reddish-brown streak. I would refer to that as a colored streak. If I try it on the dark plate, I will see it and I can more clearly see the color. So when we do streak tests, we often try it on both the black plate and the white plate. Let me give you another example. This is pyrite. Notice how it looks gold. But when I powder it on a streak plate, it creates a grayish-black streak. Still, it is a colored streak. That one might be difficult to see on a dark plate because it blends in with the background. This is why we use both plates. Other minerals, like sulfur, might give you light-colored streaks, like a yellow streak, which is more visible on a dark plate. Okay. Other minerals might give you no streak at all, like calcite. Does not leave any mark behind whatsoever, even on the white plate. It doesn't really leave anything clear. Maybe a little bit of white, but nothing terribly clear. So when you're doing these tests, you're going to determine, does your mineral leave a colored streak, or does it leave nothing or white? So again, you have two categories, colored or none or white. Beyond streak, cleavage, fracture, hardness, and luster, there are a category of other properties that we might use to identify minerals. And there are a variety of things. For example, this piece of halite could be identified based on taste. Halite is salt, and if you licked it, it would have a salty taste. Please don't lick any of your mineral samples over the next few days. Some minerals have a really unique property, like this piece of magnetite. Now, as the name implies, it is in fact magnetic. As you can see, the paperclip is stuck to it. Other minerals have more unique characteristics, like this calcite. Calcite has two really interesting properties, one of which is referred to as double refraction. If you put it over some type on a piece of paper and look at it carefully, it doubles the type. You notice how the word properties on my reference table here has been doubled as you look through it through the calcite. In addition, if I were to drop some hydrochloric acid on this calcite, it would fizz up like soda.
Physical properties of minerals. 1. Color. It is the most evident characteristics of and is usually the first property used to identify minerals. It is perceived wavelength of light that bounced off from the material and is detected by our eyes. Most of the time, composition dictates what color or hue the mineral will take, but for some, the crystalline structure will also play a role. Two. Streak. It is the color of a mineral in powdered form. Minerals show color differently when ground into fine powder. This is because the presence of smooth surfaces of compact crystals sometimes reflects light differently compared to a powdered mass. Usually, the mineral is rubbed on a streak plate to determine its color. In cases when the color of a mineral appears different because of the trace particles inside it, scientists would pulverize it to get its true color. 3. Luster. It is the behavior of light as it is reflected by the surface of a mineral. Minerals are characterized as being metallic. Minerals having metallic luster reflects luster similar to a polished metal. B. Non-metallic minerals. These are characterized by luster different from the metallic one. Often, materials that closely resemble the luster of the mineral will suffice for description purposes. Some of the descriptive terms are pearly, waxy, vitreous and silky. C. Submetallic. The mineral is opaque, dull and dark-colored. D. Waxy. The minerals look like a paraffin. E. Vitreous. The minerals looks like a broken glass. 4. Hardness. It refers to the mineral's resistance to being scratched. The harder ones are difficult to scratch, the softer ones are less resistant to scratches. In determining hardness, the mineral is tested by scratching the surface with a measurable amount of force. The minimum force applied on the surface before showing evidence of deformation or scratching will be the hardness. In the physical world, one cannot simply quantify or measure the force that is presented upon an object using the naked eye. In order to simplify things, we use a standard scale, Mohs scale of hardness in relating the hardness of a mineral with a set of minerals with known hardness. In the absence of the representative minerals present in the Mohs scale, we can still determine the relative hardness of a mineral using common household items. The table below shows the equivalent Mohs scale hardness of some items. 5. Cleavage or fracture. It is the tendency of minerals to break along planes of weak bonding. It is also described by the number of planes exhibited and the angles at which they meet. Cleavage is described as perfect, good, fair, or poor. This dependent on how sharp or defined the planes where the minerals split. In cases where there is no observable planar cleavage, the mineral is said to have fracture. 6. Specific gravity. It is a measure of the density of the mineral. It determines how heavy the mineral is by its weight to water. Specific gravity is used especially when two minerals have the same size and color. Example. Galena is 7.5 times heavier than a comparable volume of water. Seven. Crystal form. It is the external features of a mineral reflect its orderly internal arrangement of atoms. Chemical properties of minerals. The chemical properties of minerals show how the presence and arrangement of atoms in minerals. Some atoms are bound in the mineral's crystal structure. Using their chemical properties, minerals are identified by how they react to certain substances. Minerals are grouped based on their common chemical content and their crystalline structure. 1. Silicate class. It is the largest group containing silicon and oxygen with some aluminum, magnesium, iron, and calcium. Silicate class is divided into mafic, with magnesium, and felsic, with feldspar. 2. Carbonate class. It is mostly found deposited in marine environments. They have been formed from the shells of dead plankton and other marine organisms. They are also found in areas where high rates of evaporations, in karst regions of dissolution or reprecipitation such as in caves, where stalactites and stalagmites are formed. The carbonate class also includes nitrate and borate minerals. 3. Sulphate class. These are found in areas with high evaporation rate, and where salty waters slowly evaporate. During this process, the formation of sulfates and halides in water sediment interface occur. 4. Halide class. 5. Oxide class. It is the most important class, at least in human civilization because it carries histories of changes in Earth's magnetic field. They are formed as precipitates close to Earth's surface, or as oxidation products of minerals during the process of weathering. 6. Sulphide class. These have important metals, such as copper, lead and silver, which considered economically significant in the modern civilization of man. 7. Phosphate class. It contains minerals with phosphorus, antimony, arsenic, or vanadium. The phosphate class is considered an important biological mineral found in teeth and bones of many animals. 8. Element class. It contains pure native elements, usually metals, in naturally pure but semimetals like bismuth, arsenic, and antimony.
Different types of rocks. Rocks are all around us. They make up this famous formation called Half Dome, or the smaller rock formation. They can be small or seen in these canyons. A rock is a solid, naturally occurring, and is made up of minerals or mineral-like matter, like shells. Rocks can be divided into three basic types depending on how they are formed. These types are igneous, sedimentary, and metamorphic. Let's take a look at these different types of rocks. Igneous rocks are formed when magma or molten rock cools. This magma can either flow to the surface of the earth and cool quickly, and these rocks are called extrusive or volcanic, igneous rocks, and they generally have very small crystals. Or they can cool inside the earth, and these are called intrusive or plutonic rocks, and they generally have larger crystals than the extrusive igneous rocks. So up first, let's take a look at obsidian. Obsidian is an igneous, extrusive, or volcanic rock. It's made up of quartz, alkali, and feldspar. It looks a little bit like glass, and it has a hardness between 6 and 7. So there's obsidian. Next, we have granite. Granite is an igneous, intrusive, or plutonic rock. It's made up of feldspar, quartz, and mica. It has medium to coarse grain crystals and a hardness between 5 and 5.5. Next is basalt. It's an igneous, extrusive rock. It is made up of plagioclase, feldspar, and pyroxene. It is dark and dense and is very fine grained, and it has a hardness between 5 and 6. So there's basalt. Next we have scoria. It's an igneous volcanic rock. It's made from feldspar, augite, and also hornblende. It is basalt with cavities filled with other minerals. And finally, we have rhyolite. It's an igneous extrusive rock. It's made from feldspar, quartz, and mica. It has a very fine texture, and often it has a porous texture, and it can float in water. So there we go, 5 igneous rocks. Sedimentary rocks are formed from pre-existing rocks or pieces of once living organisms. They form from deposits that accumulate on the Earth's surface or under the ocean. These particles that form a sedimentary rock are called sediment and may be composed of minerals or once living matter called organic matter. Sedimentary rocks can be divided into several groups. Some common groups include clastic sedimentary rocks, which form from fragments of pre-existing rocks, chemical sedimentary rocks, which form by precipitation of minerals from water. Precipitation is when dissolved minerals come out of water. And organic sedimentary rocks, such as coal and limestone, which form from the accumulation of plant and animal debris. Clastic sedimentary rocks are subdividing according to the dominant particle size. These particle sizes are ranked from smallest to largest. Clay is the smallest, then silt, sand, gravel, pebble, and boulder. Up first, shale. Shale is a fine-grained, clastic sedimentary rock composed of mud. This mud is a mix of flakes of clay minerals and silt-sized particles of other minerals, especially quartz and calcite. Shale is very fine-grained. Next, let's look at sandstone. Sandstone is one of the most common types of sedimentary rock found throughout the world. It is a clastic sedimentary rock composed of sand-sized grains of mineral rock or even organic material. It also contains some cemented material that binds the sand grains together. Next, conglomerate. Conglomerate is a coarse-grained clastic sedimentary rock composed of pebbles and boulders. The space between these pebbles and boulders is generally filled with smaller particles of calcite or quartz cement that binds the rock together. And finally, limestone. Limestone is an organic sedimentary rock that is often composed of the skeleton fragments of marine organisms such as coral. About 10% of sedimentary rocks found on Earth are limestones. Metamorphic rocks come from existing rocks that are subjected to extreme heat and pressure. This heat and pressure changes the original structure into a new type of rock. Sedimentary, igneous, and even metamorphic rocks can all become metamorphic rocks when exposed to heat and pressure. The original rock is the protolith, but is commonly referred to as the parent rock. Metamorphic rocks can form deep in the Earth's crust or at areas of plate tectonic movement. Two major types of metamorphic rocks are foliated rocks, which have crystals in stripes, and non-foliated, which do not have crystals in stripes. So let's take a look at some common metamorphic rocks. Slate. It has very, very small minerals. It is considered foliated, and its parent rock is shell. Marble has fine to medium crystals. Its parent rock is limestone, and it's considered non-foliated. Quartzite is a non-foliated metamorphic rock, and its parent rock is sandstone. Gneiss is a foliated rock, and its parent rock is schist. And finally, schist is a foliated metamorphic rock, and its parent rock is slate.
Rocks. Rocks are natural substances consisting of aggregate minerals clumped together with other earth materials glued by natural processes on Earth. Rocks, like other materials on Earth, are recycled. This cycle is never-ending, and it describes the dynamic transitions through geologic time. In the process of transformation from one rock type to another, various substances are combined or formed. Rocks may contain other non-mineral materials embedded in it, such as fossils and glass. Like minerals, rocks are very useful in human civilization. Types of rocks. 1. Igneous rocks. These are formed from the cooling and solidification of molten or partially molten volcanic material that came from within Earth like magma. 2. Sedimentary rocks. These are rocks that have formed from different material deposits on Earth's surface. Sediments may be precipitates from the evaporation, or also pre-existing rocks or pieces of dead organisms that have been lithified or cemented together by the natural processes on Earth. These rocks usually show a distinct layering or bedding on the surface. Most sedimentary rocks are found in beaches, rivers, and oceans where sand, mud, and other type of sediments are present. They preserve or record the kind of environment that existed while they were being formed. Three. Metamorphic rocks. These are rocks that are formed from igneous or sedimentary rocks that are exposed to high pressure, high temperature, or a combination of both, deep below the surface of Earth. Because of this exposure, some of the minerals in these rocks undergo chemical and physical changes. Metamorphic rocks are commonly used for building materials, artworks, and decoration, and as component of toothpaste, plastics and paper.
To summarize our lesson, minerals are naturally occurring in organic solid with crystalline structure and chemical composition, which may be fixed or vary within certain limits. They are the building blocks of rocks. There are different physical properties of minerals. Number 1 is color, which is the most evident characteristic. Number 2 is strake, the color of mineral in powdered form. Next is luster. This is the behavior of light as it is reflected by the surface of a mineral. Next is hardness. It refers to the mineral's resistance to being scratched. Next is cleavage and fracture. These are used to describe how minerals break into pieces. Next is specific gravity. This is the measure of the density of the mineral. There are other physical properties which includes the following: odor, tenacity, crystal form, and transparency. The chemical properties of minerals show how the presence and arrangement of atoms in minerals. Minerals are grouped based on their common chemical content and their crystalline structure. These groups are silicate class, carbonate class, sulphate class, halide class, oxide class, sulphide class, phosphate class, and element class. Rocks are natural substances consisting of aggregate minerals clumped together with other Earth's materials glued by natural processes of Earth. The types of rocks are the following. Number 1, igneous rocks, which are formed from the cooling and solidification of molten or partially molten volcanic materials that came from within Earth. Next is sedimentary rocks. These are formed from different materials deposited on Earth's surface. And last is metamorphic rocks. These are formed from igneous or sedimentary rocks that were exposed to high pressure and temperature deep below the surface of the Earth.
Activity. Answer the following. 1. Summarize the different characteristics that define mineral. 2. Which among the following mineral groups, if any, contain silicon, halides, carbonates or sulphides? Explain. 3. Which is more abundant in the Earth's crust, silicates or all other mineral groups combined? Explain. 4. An unknown opaque mineral has a black streak and has a density of 18 gram per cubic centimeter. Is the mineral metallic or non-metallic? 5. How does streak differ from color, and why it is more reliable for rock identification? B. Identify the term described in each item. 1. It is the study of minerals. 2. It refers to the color of the mineral in powdered form. 3. It is the hardest mineral on Earth. 4. It is the appearance of the mineral surface in reflected light. 5. It is the weight of a mineral compared to the weight of an equal volume of water. 6. It is the resistance of the mineral from being scratched. 7. It is the resistance of the mineral to break along planes of weak bonding. 8. It is the building blocks of rocks. 9. It is the most important class of mineral because they carry histories of changes in Earth's magnetic field. 10. This class of minerals are the largest group containing silicon and oxygen with some aluminum, magnesium, iron, and calcium. C. Classify the following rocks in the first boxes to igneous, sedimentary and metamorphic. Granite, marble, basalt, gypsum, conglomerate, calcite, slate, schist, pumice, sandstone, diorite, quartzite, halite, andesite, limestone.
I hope you learned from our lesson. See you in the next topic.